Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois, and this video is going to take a look at the introduction of C++ STL Standard Template Library Algorithms, and this is a homework assignment that I gave to my C++ for Gamers class, and oops, I didn't mean a second here, and we'll do that, get there in a second. And so the standard template library has, I believe they said 60. I don't remember exactly how many. They have quite a few different algorithms, and an algorithm is just a way to solve a specific type of problem. And so you can write your own code. There's nothing that says you can't write your own algorithms to handle finding things and accumulating things and transforming things and all the things that the standard template library has for you. But what the standard template library has going for it is some very smart people have written some very efficient code, and it's been tested and tested and tested to holy hell. You do not have to worry under almost every single circumstance that there's any bugs in the code that you're going to be using under the hood in the standard template library. It's been over, how many years has this thing been around versus your code that you wrote as fast as you can to get a job done. And we've all been there where you make a mistake, a simple mistake somewhere, and in some cases you find the mistake maybe 6 months later or years later, depending on the size of your projects, and that's because you tried to cut a quick corner and when the STL was there for you all the time. So we're going to be using 4 algorithms to get our to solve the problem you'll see here in the next slide. We're going to use next permutation, find, accumulate, and transform. And of course, once you understand the basics of how to get these things going, then you just have to look into what the algorithm does, how to supply the parameters to the function, and what it returns, and you're good to go. And so the problem of the day is a different style of picking game than the ones I've had for other videos. And so in this case, there are 8 tokens to choose from. Everything has a value from 1 to 7. There's a unique number from 0 to 7. The 0 is what we call the pooper. That's the one that kicks you out and you lose the game, and whatever you've won up to that point you accumulate. And so the rule, just to make this a little more interesting, is to say if you pick the 0, the pooper on the first pick, you win everything. So that would be 28, I believe, is the number of credits. 1 plus 2 plus 3 plus 4, that kind of thing. And so you would win 28 credits if you pick the 0 on the first pick. Otherwise, the first pick is non-zero, and then you continue until you pick the 0, and then the game ends. So that's, and then we go back to the base game or whatever the game ends at that point. So my question to you is, if you pay 1 credit to play, how many credits, what is the expected value? What is, if I play this every possibility, and I play this an infinite number of times, on average, what value am I expected to get out of this thing when I play this thing over and over and over again? And so then once we figure that number out, then we'll figure out what can we multiply all these values by? What can I multiply this thing to turn the expected value into 10,000? And that should be a simple multiplication that will tie into our final algorithm of the day. Okay, so our first step is to learn how to use the next permutation algorithm so that we can go through and print out, or just to see every possible combination that these 8 things can go. And just to think, it should be 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That should be the answer that comes out of this, of how many different permutations there are. So let me just set up a vector of ints. And I'll call them picks or something like that. And I'll make this easy on myself, and I'll just put everything in order since we're going to be generating all the permutations. And I'm going to set up a value for I'll just call it perms, and I'll set it to 0. And what I will do is, what did I do wrong here? And what I'm going to say here is I'm going to do a do while, and I'm going to say do while picks std next permutation, and I'm going to say picks.begin and picks.end. There's a few things going on under the hood here when I do this. And I'm going to say equals, make sure I do this right, equals true. So if I mouse over the next permutation, you will see it returns a bool right here. Returns a bool, yes or no. Did it generate a new permutation or not? And then what it does is you give it iterators for the beginning and end of, because I can do this for just subsets of the vector, but I want the whole thing. Start from the beginning, go to the end, and basically just continue generating new permutations. And in this case, I'm going to do plus plus perms. And then when I'm here, I'm going to print out permutations. And I'm going to print out perms. And then I'll print out an end line. And when I run this, I get 40,320, which is 8 factorial, which is the answer I'm expecting to have. And so what's happening here under the hood, perms is getting incremented. This thing is generating. It's actually modifying picks. And I really don't want to go ahead. I wish it was Python where I could just write one line of code. But every time, oh, maybe I should. I'll just do this real quick. What the heck? Okay, so I will go ahead and I will set up a function print vector and const std vector int reference v, and I will go ahead and say for every integer, I'll just call it I, that's in v, go ahead and print go ahead and print I, and then I won't print a, should I print a space between them? Yeah, whatever, we'll print a space between them, and then here I will print an end line. And just for the sake of this, I'll add to the perms here, and then I will say print vector. And I will print picks. And so you can see, again, there's going to be 40,000 different lines, and it's going to, I'm not going to, I don't know how long I'm talking and how long it'll take to do. I guess it's getting faster. But you can see it's generating every permutation that can occur from all the 40,000 different ones of them. And so you have to watch out when you're doing, when you're thinking discrete math and you're thinking these kind of things, that permutations and combinations are not the same thing. So like you have to watch out. If I made this like this, if I made duplicates on the ones, you would think there'd be 40,000 permutations. But as it turns out, because of the duplicate one, I think you end up with half of that number. It should be 20,000 something, 20,160. And again, I'm not getting into the math of combinations versus permutations. This is an applied math representation here. And so just to say you have to watch out for that, you have to come up with different code if you want to do combinations versus permutations. Okay, so coming back, we're good there. I don't really need this anymore. I just wanted to show that. So now that we have every permutation, now we can go in and figure out and use a find function to figure out where the 0 is. Because what we're going to do for every permutation, since it's generating every single one, I'm just going to presume I'm starting picking from the left, the leftmost element, and I'm just going to pick until I get a 0. I mean, I want to figure out where the 0 is in here, and then basically, if I get a 0 on the first, I'll sum everything up. Otherwise, I'll just sum up everything up to the 0 point. That's my goal. So then this is a perfect opportunity to use the find function, the find algorithm, and it returns an iterator. And what I'm going to do here, I'm just going to call it iter, and I'll say it's equal to, and I'll say std find. I say, okay, inside of the entirety of picks, take begin, take end, go through the entire thing, and search for the 0. It's in there, a matter of this or that or whatever. And so what I would love to do is sum everything up. But what we discussed, the little tricky part here is to say that if the first pick is a 0, then everybody goes. So let me just say, so like I go through everything. So if iter equals, and I say then picks.begin, right? Because the begin iterator will give me the first element in this thing. And if the 0 is the first element, then I need to count everything up. So I'm just going to then say iter equals picks.end. Because I'm going to use, now that I use the find function, I'm going to use accumulate to actually do the hard work. I'm not, there's no reason for me to go through the vector manually when I can write one more line of code now and just do the accumulation. Okay, so now from this, I can use accumulate. And it does exactly what you would think. I'm going to go ahead from pix.begin all the way to iter, wherever that is, and I'm going to accumulate, and I'm going to add, and I'm going to say perms, and this takes 3 parameters. What is accumulate? Did I spell it wrong? Maybe it's not an algorithm. So let me check. Maybe let me just do a real quick check here while I'm talking, thinking about things, and I will check to see what. Maybe it's not an algorithm. Okay, so accumulate is actually found in numeric, the numeric include instead of algorithm. Everything else is going to be found there. So just so you say, no big deal there. So one little thing I neglected, since I neglect a lot of things apparently, is the number of wins needs to be maintained. Number of permutations is maintained already, which is the 40,000 value we're looking for. And so I just wanted to redo this now that I have my understanding. There's 2 ways to go about doing this, and I'll show you the easier way is just to say the number of wins is plus equals. If I take my accumulate, and I go ahead and I say, okay, pix.begin, and then iter, because that's the end point. It's not the whole thing, it's wherever I tell it. And then I'm going to use 0. Because 0 is what do I start accumulating from as I'm going ahead and adding the values as I go through this vector. And so 0 is a great one. And so this returns an integer value, which is the accumulation of everything from begin to iter. And so I can just tack that on to whatever's already in my wins. The other way to go about doing this is to say something like this, which is up to you. Whichever, start with wins, whatever the current value is, add everything, return that value back, and then store it again, and redo and redo and redo. So it's whatever you want it to be. At the moment, I like this guy. And so let's see what we get. And so number of wins divided by the perms, and I'm going to static cast this so we can see the end result here for the fractional component. I think I know what I'm expecting to see, but let's see if my expected value is the number I want it to be. And it comes out, yep, there it is. It comes out to 17.5. So if I pay you $1 to play this game, if on average, I will win 17.5 credits. And again, as a bonus game, that's fine. As a casino game, it's terrible. If I paid you $1 and I won 17, no, yeah, on average, yes, the casino would never allow this, of course, to happen. So, okay, so now to say the final step here is to say, okay, we have 17.5 as the expected value. What was that multiplier I can use in order to get this thing to 10,000 credits? And so you say, so basically, if you want to think of it, fire up the old calculator and say what I could do here is multiply every element in that vector by, and 0 is included in this because it's multiplication, is to say 10,000 divided by 17.5. So the answer, this is the answer. So 571 as an integer gets me as close as possible to the final answer of 10,000 for my expected value. So it's going to be slightly under or slightly over the 10,000 value. Yeah, so when we use 571, it'll be slightly under. So 3 ways to do this. You could just go ahead and turn just basically manually type in 571, 1142, and you could see how tedious that is. You could go ahead and set up a for loop and go ahead and say for every element in here, multiply equals. But the final, so we've used find, we've used accumulate, we've used next permutation. The final one I want to use today is the transform, which basically does exactly what you think it will. It will go through like a selection inside of a vector, and you can supply and say, I want you to transform the values into some other values, and I can tell it where to copy the new values to. But in this case, I want to copy it right back. I want to turn a 0 into a 0. I want to turn a 1 into 571, and so forth and so on. So I could say, okay, there's four things I have to do here. And I can say, okay, I want to take pix.begin, I want to take pix.end, because I want to do the entire thing here. And what I want to do third here is where's the destination? I want everything to start going back. It only takes one parameter and everything moves forward, since we're using something, basically a vector, which I can go from element to element. So this means starting at begin, put the value in begin, and then this iterator will shift over 1, but this iterator will shift over 1 as well. So it'll continue to work its way through here. So now the final step here is a function. I need to supply a function in order to do the transformation. And since, why not throw this in? There's a few ways to do this. I will show you guys how a lambda works. So a lambda is basically just an anonymous function. You've worked in Java and you've worked with listeners and you've worked with lambdas in other languages, or just JavaScript. You've basically done this before, but of course the syntax is going to be a little different than what you're probably expecting. This is C++ after all. Are you expecting it to look pretty? Who's expecting that, right? So the general format is it's just one of those things where you use the square brackets, and this indicates, you say, what am I trying to do? I'm trying to take an input value, because what's going to happen is this function is going to be called over and over and over again for every element inside of the range here of pix. And so in this case, everything is going to be an integer coming in. I'll just call it x, because pix is a vector of integers. So every element is going to be an integer that gets passed into this thing. And what I would love to do is just return. So x comes in, and 571 times x comes out. And that is, it's ugly as sin, right? But that is a lambda. This is saying this is a function, and I want to take whatever x comes in, returns 571 out. But what is this square bracket for? The square bracket would be, if I wanted to do something like this, const int multiplier equals 571, and I replace this like this. You should get an error. Don't you get an error? Let me build this and let's see what happened. Didn't say success. So it said multiplier cannot be implicitly captured because no default capture mode has been specified. And say this is just a quick and dirty. If you want to know what that error message means, go look up lambdas. But what it just means is that essentially in this function doesn't know about anything from the outside world. So basically it's the same as saying I can't find what multiplier is in this lambda. And that's what the square brackets are for. I can say, oh, go outside to find multiplier. And you can supply everything in as value, as by reference, and so forth and so on. And now you notice that it succeeded. And so now it says, I'm going to use the outside of this function to use the multiplier, but you're going to pass in x from this, and then multiply the two values together, and then it's going to be put back into its place. And I do all the work, all of that put together, and say I didn't, it generally goes on the same line, but there's right now, I guess I can do something like that. You can see it all now and say this is where things start to get very ugly, but you get the point here. The answer comes out to 9,992, which is very close. As I was saying, you're not going to get perfect, especially with integer values. But as you see here, we get what we're looking for, and transform did that. And just to show, let me put a breakpoint right here, just to show you what happened. Oh, let me put the breakpoint. Let me start over and put the breakpoint here. That pix is 0, 1, 2, 3, 4, 5, 6, 7, and by calling this transform function on this now, pix becomes 0, 571, 11, 42, and so forth and so on. And I especially don't have to do this by hand. And then when the boss comes by and goes, well, 571 is terrible, why don't we use 400? You don't have to do all the math over again. You just have to change the value here in this one place. So that solves the entirety of the problem that I had for the homework assignment, and the task at hand for our homework assignment here. For this video. So as always, swardb@cod.edu is a great way to get a hold of me. the comments here on YouTube is also a great way to get a hold of me if you have any questions about today's lesson. So thanks for sticking it out as always. Have a great day, have a great week, have a great weekend, whatever you're having, and I'll see you next time.